that is just my countdown for the recording. Okay. All right. So oligopoly. We started last week, right? Thursday we discussed a little bit about oligopoly and some characteristics of oligopolistic farms. Let's do a little bit of review, just to make sure that we're on the same page, and then we can hop on into the next new stuff. Okay. So what do we remember about oligopolies?
And there's game theory.
Okay, yeah. So that's the new stuff. Let's say like some characteristics, in terms of how many farms we're talking about, the type of product.
There are barriers up to entry.
Okay, good. So barriers, there are
barriers of entry. There is some sort of differentiation in the product.
Okay.
Not really.
So okay, let's.
There are cartel.
Let's try some other ones. Judith and Moe, I see that you guys are here on Scribblers. Are you on Hangout? Or are you on the Google Meet yet?
Yes.
Okay.
Julia, what link are we using?
So
I'm here.
Okay, so this is the Google Meet, the link to the Google Meet.
There are a few large firms.
Good. Yeah, so that was one of the key characteristics of few large farms, right, that sort of dominate the industry. We said that they were top heavy. So, 3 or 4 large farms will have a good percentage of the market share in terms of, products, production, and also sale. And then we said that there were really good barriers to entry, so it's not impossible, but very difficult to enter this kind of market.
And there's differentiated and standard product.
Good. So they sell both differentiated and also standardized or identical products, right? So what were some examples of differentiated products?
It was like
Jaime, I know you know this stuff. I'm gonna ask someone else, okay? So Max, what were some examples of differentiated products?
Can you repeat the question?
So I'm just asking, remember we said that, oligopoly, they tend to create, both type of products. Sometimes they will create products, or, some oligopolies will sell products that are different, right? And some will sell products that are, kind of identical. So do you remember what the oligopolies that sell differentiated products, what some of those products might be?
Maybe cars.
Good. Yes, cars are a good example, right? We want variety in the type of cars we want to drive. So, and they're differentiated, right? Not all the cars are not the same, even though they might have similar features. But of course, there are also differences. Cars, we said soft drinks, cellular phone services.
Okay.
All those are examples of oligopolies that sell slightly differentiated products. And what were some examples of oligopolies that sell standardized or sort of identical products?
Crude oil.
Yes, crude oil, aluminum, steel. So these, sorry?
It's mostly natural resources, right?
Yeah, so like they're mostly producing what we call intermediate goods. So we don't use these stuff, right? Crude oil, aluminum, steel, like for our consumption per se, but we use them to make other products that are then used in consumption, right? So these are things that we actually use ourselves, right? To consume, but we don't necessarily consume these things. We use them for other purposes, aluminum, steel, right? To make other stuff that we can actually use for consumption. Okay. And then lastly, there was another point about interdependence. interdependence. Does anybody remember what that was?
Yes, that one action of one person affects the action for the other firm.
Yes. So in oligopoly, farms are mutually interdependent, which means that the action of one farm affects others, right? So they kind of have to look out. They not only have to worry about their own actions, but also how the competitive rival farms might sort of respond to their actions, in terms of, if they go high price or if they go low price, how will the rival farms will sort of respond to their strategy. Okay. So something I want to correct from last time that I said that was not quite correct is, when we were talking about non-collusive behavior, somebody, I think Jaime, you asked, whether it was oligopoly behaviors, not the collusion, but the non-collusion, when they are not colluding with each other, but, they just sort of, do things independently, right? But they also have to look out for the reaction of their rivals. So you asked, whether this was similar to a game of chess, right? And I said, yes, I guess it is quite similar. I might have said that it was similar. So that's not quite correct, because in oligopoly, so the game of chess, we would call this a sequential game, right? Because one person makes a move, and then you make another move, and then somebody else makes the other move, right? So it happens, one person goes and then another person goes. But in oligopoly, the kind of game that we're going to be talking about in game theory specifically are what called simultaneous games. Okay, so here you don't really know necessarily like what the other person is doing, and it's sort of like the rock paper scissor, that game, right, where you sort of have to reveal what your strategy is, whether you're choosing rock paper scissors. Everybody does it at the same time, and then depending on who picked or who chose what strategy, the outcome is then decided. So it's not like chess, where you see the action or the strategy that this one person is taking, and then you can decide your own strategy. This is simultaneously. This is happening simultaneously, where you don't really know what the rival is doing, and you don't know their actions. Okay, so I just wanted to make sure that we got that. So then we also talked about this idea of concentration ratio, where economists use this to understand how much market share is held by the few large farms in the industry. So usually we do it with 4 or 8 large farms, right? And here you just add up the market share that is being held by the 4 large farms or the 8 large farms. So you just basically just adding them up. Okay. And then we talked about oligopoly behavior, right? So oligopoly farms can either choose to make their own decisions, which would be, if they make their own decisions and don't really consult or, talk to the other party, their rivals, we call that non-collusion. And if they do talk and meet with their rivals to make pricing decisions, we call that collusion. And collusion is something that is illegal, right? You cannot do this because, if you do this, essentially you work together with another farm to create a monopoly, right? So, with that, you restrict output and you raise your prices, and that's not beneficial for society. So government doesn't really like it when farms collude, so that's why it's illegal, right? And then when groups of farms create a formal agreement not to compete with each other, we call them a cartel. And we said that the most prominent example of cartels in our world today is this example of OPEC, the Organization of Petroleum Exporting Countries, that have this formal agreement, about global oil production and sales. Okay. then that was we looked at collusive behavior, we looked at non-collusive behavior, or we briefly talked about it. When you are non-colluding, right, which means that you kind of are not coordinating with your rival. You do your own thing, and then your rival does their thing, but you sort of always have to worry about what your rival is doing. Okay, so this is as far as we got. So I kind of briefly talked about this in words, but we're gonna see when we talk about game theory and the payoff matrix, how this sort of plays out. Okay, and the reason we have to talk about this thing called game theory is because of all of this comes from this idea of interdependence. Okay, so because we know that farms in oligopoly are interdependent, they're affected not only by their own decisions about the price or how much to produce, but also by the decisions of other farms in the market, right? So because of this complexity, right, that that your decision is not the only thing that matters, but also what your rivals are doing is very important. So because of this complexity, there is really not a single generally accepted theory about how oligopoly farms behave. So for the other ones, when we talked about perfect competition, we talked about monopoly, we talked about monopolistic competition, right? We were able to draw graphs, and we were able to perfectly say how much they're going to produce and what their demand and marginal revenue, all of that looks like. But this is very hard to do with oligopoly, because it's not only just about your own demand, but also about what the other guy is producing, how much he's producing. So it gets rather complicated. So this is why we sort of economists sort of bring up this other this thing called game theory, which is basically just a branch of mathematics. And it what it does, this game theory, it offers sort of like a good framework for understanding how farms actually act in this context of interdependence. Okay, so I know it's a lot of word that I'm saying right now. It's hard to understand. It's very abstract, that you're not really seeing it in action. But once you see it, hopefully it will make better sense. But I'm just trying to give you a lay of the land in terms of like why it is that we need to look at this thing called game theory, to understand. Because it sort of works as a model, right? So it sort of acts as a model, and it can model situations in which each player, game has players. So here we'll see that we'll have players. So we can sort of use this game theory to model situations in which each actor, while they're deciding what kind of action to take, they also have to consider how others might respond to that action. So this is what we will see here. Okay, so this is what we use. So this is with game theory, right? This is sort of a visual representation of what a typical game theory payoff matrix will look like, and likely what you will see on the AP exam if you have questions on game theory. So most likely you will have something. So this table is we call that a payoff matrix. Okay, so it's just a table that shows the results for different players under different strategies. So I'm going to tell you what all of these means. Okay, so here, look at the top, right? We have something called farm A and something called farm B. So these, right? So these two are your players or actors. Okay, so farm A is one player. So usually the one on the left side, we call them player one. And then the one on the top, okay, we call them player two. So player or actor, most likely you'll see player. So player one is farm A, player two is farm B. And the numbers that you see here next to the cells, right? So sorry, not the numbers, the letters here, right? Here it says strategy X, strategy Y. So these are for farm A. And then for farm B, you have the same thing, right? You have strategy X and strategy Y. So these are essentially exactly as it says. So these are the different options that these two farms have available. So farm A can either choose strategy X or strategy Y, or option X, option Y, and farm B can do the same things. They have strategy. They can either choose strategy X or strategy Y. And then we have we have 4 different cells, right? And each cell have some words inside of them, right? So what each of these things inside the cells mean, right? They're called payoffs. Okay, so how do I write this? Maybe like, so this is a payoff. Okay, a payoff is basically what you get from playing the game. Okay, so it's just a result or an outcome of playing the game. So here, all the numbers on the left hand quadrant, I guess you could say, like the left hand side of the cell, so of each cell. So here, as you can see, the result for A, the result for A, result for A, result for A. So all the numbers that are that reflect the payoff for farm A, right? I have written them in red. Okay, so that's just one way for you to remember. So anytime you want to find what the payoff or the outcome for farm A is, it's always going to be on the left hand side. Okay, so A is always going to be on the left hand side, or not A, the player one. So the player on the whatever, the farm or the player that you have on the left hand side, the results for them is also going to be coming first. Okay, and for farm B or player 2, these are his outcomes or payoffs. So results for B, as it says on each one of these cells, these are going to be on the top hand quadrant. So before the slash, this diagonal thing, so this is the result. These are the results for A, and then after the slash, these are going to be the results for B. Okay, and the way we sort of analyze or read this thing is from left to right. So let's say if farm A chooses strategy X and farm B chooses strategy X as well, right? So this cell is where we would find the result of choosing those strategies for each farms. Okay, and the same way, if farm A chooses strategy X but farm B chooses strategy Y, would be located in this cell, and the payoffs would be corresponding to these strategies. And if you would do the same thing for the other two, right? If farm A chooses strategy Y but farm B chooses strategy X, would be located over here in this cell. And if farm A chooses strategy Y and farm B also chooses strategy Y, would be located here in this cell, and then the payoffs would be corresponding to these strategies. Okay, any question here in terms of understanding how to read the table? Hello?
Hello.
Okay, so now let's actually take a look at an actual example. These are all words, and they're not so easy to wrap your head around. So let's actually take a look at an example and see what we mean. Okay, so here we have this payoff matrix, and the two players here are Drake and Eminem, the two rappers. Okay, and they have different strategies that they can choose. So for Drake, the two strategies are either he can release a single or he can release an album. Okay, and for Eminem, he can either do a video or he can do a concert. Okay, and the numbers, right, correspond to the payoffs. So the numbers, right, are the payoffs for corresponding to each one of the strategies. So if I say, if Drake chooses a single and Eminem chooses a concert, the payoff for Drake would be 3, right? So I just go over to the row that has single for Drake over here, and then I pick the column that says concert. So I'm going to be over here located in this cell. So the payoff for Drake is 3, and the payoff for Eminem for doing a concert is 4. So the numbers here, can be anything. They can sometimes be profit. They can be different things, like as we will see later. So here, just imagine that they mean like millions of dollars or something. Okay, so like $3 million or $4 million, right, for Eminem. So $3 million for Drake if he releases a single, and $4 million for Eminem if he does a concert. Okay, so now how do we go about analyzing this thing? Okay, so the way we do this, okay, is we're gonna look at it from, let's say if we are Drake and we need to decide whether it is better for us to do, like, to release a single or to do an album. So the way we're gonna do it is, if we are looking at it from Drake's point of view, okay, so remember the numbers in red, right, represent Drake's payoffs, right? Those are his results. So if I am Drake and I am trying to decide whether to produce a single or an album, I'm also going to have to take in account what Eminem is doing. So let's say I have some intel, right, intelligence, like, and I sort of know that I'm thinking like Eminem is going to do a video. So the way I'm going to read this is, if I know that Eminem is doing a video, so this column doesn't exist right now. Okay, this column about concert, like, imagine that there is a blank, or this doesn't exist. Like, there's a crossover here. So we're only going to be looking at this column, okay, and I'm going to be comparing Drake's payoffs. So if Eminem does a video, is it better for Drake to do a single or an album? So if he does a single when Drake does a video, he gets $5 million. And if he does an album when Eminem does a video, he gets 10. So which is better?
And the one with the album, because he gets more money.
Yes. So of course, we're looking for, which is better. So in this case, if this is profit, so the $10 million, of course, beats 5. So in this case, if Eminem does a video, it is better for Drake to do an album. Okay. So now we're gonna switch and we're gonna think, okay, now let's take a look at this. We're gonna pretend that this column doesn't exist right now, and we're going to only be looking at this column. Okay, so if Eminem is doing a concert, now what is the better option, single or album? So which numbers are you going to compare?
And we're going to compare the ones in red to the ones in black.
So you're not comparing the ones in red you're only comparing. So that Eminem is only doing a concert. So this is not in question, right? So you're only comparing. So knowing that Eminem is going to do a concert for sure, what am I better to do? If you are Drake, are you better off doing a single or an album? So you're only looking at your own numbers, right? What is my best response knowing that Eminem is doing a concert? Album, right? Because 7 beats 3. So here. So you can do circles, you can underline, whatever works for you, just to let you know that this is what I am choosing. So here, what do you notice, right? For Drake, regardless of what Eminem is doing, whether he does video or he does concerts, he is always choosing to do an album, right? So when something like this happens, we call that a dominant strategy. Okay, so here we see that Drake's dominant strategy is to produce an album, because regardless of what Eminem is doing, even when Eminem does video, he is better off doing an album, right? Or when Eminem does in concert, he's still better off doing an album. So Drake actually has a dominant strategy, which is that he should release an album. Okay, a dominant strategy is exactly what I just said. It's when one player, right, has one action that he can choose, right, that gives him the best payoff regardless of what the other player is doing. So here it is better for Drake to release an album because it always gives him a better payoff regardless of what Eminem does. Okay, and now we're going to switch perspective and look at it from Eminem's point of view. Okay, so now if we are Eminem, right, we are deciding whether to produce a video or to do a concert. Okay, and we're gonna have to, of course, take into account what Drake is doing. Okay, so now we're gonna do this, right? When we are looking at Eminem's, right, we're gonna pretend that this row doesn't exist. So I pretend right now that Drake, somehow I know that he's going to be producing or releasing a single. So what is better for Eminem to do a video or a concert? So I'm looking right now, what am I looking at? What are the numbers?
We're looking at our Eminem's numbers when comparing them and seeing which one helps us benefit, because we already know Drake is going to do an album.
So no, you don't know, like, imagine that doesn't exist right now. Okay, so now we have switched to Eminem's perspective. Okay, so we're just forget it that Drake has is gonna be creating, or that is his dominant strategy. So right now I'm asking you, like, let's say if I'm Eminem and I'm choosing between a video and a concert, and I know that Drake is going to be releasing a single, what am I better to do? Video or a concert? Concert, right? Because that gives me the better payoff, right? Between 2 and 4, because those are Eminem's numbers. Remember, always on the top quadrant. So those are the 2 numbers. So he's better off doing a concert. And what if Drake produced an album? What is Eminem better off doing?
He's better off doing the video.
Exactly, because 9 beats 7, right? So because those are his 2 choices, right? He can either do a video or concert. So video gives him 9 millions, whereas concert gives him 7. So does Eminem, yeah.
How do you know, like, this is preset, like they tell you like what number goes in each triangle?
Yes, they will tell you
there's
that.
a way to figure it out?
No, they will have to tell you that. The numbers you'll be given. You'll just have to do the analysis.
Like, what's the most difficult analysis question that we can get out of here?
So let's see. So what is Eminem? Does he? So you might be asked questions about dominant strategies. So does Eminem have a dominant strategy?
No.
What is dominant strategy?
Remember, we said that it is something like, is there one particular action that you can do that gives you a better payoff regardless of what your opponent is doing? So with Drake,
Concert.
Okay, so with Drake, remember, we saw that regardless of what Eminem was doing, he was always better off producing an album. So this is why I underlined those 2. In both instances, he was better off doing an album. But with Eminem, we just saw that the numbers, right, they're not in same row, right? The numbers that we underlined. So in one instance, when Drake produced a single, he was better off doing a concert. But when Drake produced an album, it was actually better for him to do a video. So when that happens, right, he has no dominant strategy, because he had to change his strategy based on what Drake was doing, right? So it wasn't like Drake, when regardless of what Eminem was doing, he was always better off doing the album. So with Eminem, it was not the case. So he actually doesn't have a dominant strategy. Okay.
And how is there a name like to say when there's a tie, for example, in concert and album here,
what do you mean?
like both are 7?
Oh,
How do you call
no, it's just the payoffs are the same. So we don't, there is no name. Yeah, but there is something that is interesting about this one. Okay, so so after you have done this and you have figured out what the dominant strategy is, okay, look at this cell over here. We underlined both of these numbers, right? So when you have one cell, when we're doing game theory, if you have one cell where both numbers are underlined, we call that a Nash equilibrium. A Nash equilibrium essentially is something where you are choosing the best thing for yourself, okay, depending on what the opponent is doing. So choosing the best action, but depending on what your competitor is doing. Okay, so when you have a Nash equilibrium, okay, let's see, I actually have the definition over here. So a situation where both players choose the action that is best for them given the action of other players. Okay, so this is what we have in that cell in 10 and 9. Okay, so this one over here, we call that a Nash equilibrium. So the reason this is the case that we call this a Nash equilibrium is because when we are in this cell, right, we have none of the players have any reason or any incentive to move away from this equilibrium, from this choice, let's say. Because let's say if Drake decided to do an album, okay, so if we're saying that this is the Nash equilibrium and this is the best action for both players depending on what the other player is doing. Okay, so the reason we know that this is a Nash equilibrium because moving away from this cell, right, would actually lower their benefit. And we can check this by looking at it this way. So if Drake does an album, right, so if Drake keeps doing an album, does Eminem benefit from moving away from doing a video? So if Drake does an album, is it better for Eminem to do a video or a concert?
It is better for Eminem to do a video.
Yeah, so does he benefit from moving away from this choice? No, so he doesn't benefit. So that's why, so that's for Eminem. So let's check it for check the same way for Drake now. So if Eminem does the video, right, we're here, does Drake benefit from moving away from this cell? So his choice now would be, if Eminem is doing a video, right, his choice is going to be between 10 and 5. Does he move away from producing an album? Does he benefit from moving away from producing an album? No, because 5 is lower than 10, right? So neither player can actually benefit from moving away from this choice or this cell, which is an equilibrium. So this is what we know as the Nash equilibrium. So both are doing their best. There is no regret. Okay, they're doing the best that they can in response to what the other person is doing. Okay. Does everybody, or at least sort of understand, what's going on here? Do you guys have any questions? So as we go through more examples, this will become more clear. Okay, so let's do some more examples. So here what we have is a classic example of game theory that is used a lot in game theory. Okay, so it's a specific type of game in game theory that sort of illustrates why cooperation is difficult to maintain for oligopolies, even when it is really beneficial for them. So remember, when we talked about colluding and cartels, we said that for cartels it's kind of hard to maintain that cooperation, and there's always an incentive to cheat. So this is sort of a classic example of what happens there. So in this game right here, we have two players, Jack and Diane. Okay, so they have been arrested and put in prison. Right, they're members. Let's say they're members of some kind of criminal cartel or whatever. So they have been arrested and put in prison by the police, and now they have been put in separate interrogation rooms, and they've been given some choices. So the police thinks they committed some kind of crime, but they don't really have any sort of hard evidence to against them. So what they're trying to do, basically, the police, is by putting them in separate rooms, is trying to get one of them to sort of confess and testify against the other. Okay, so these are the choices that they have been given, and they don't know, they can't talk to each other, they can communicate, but they're just gonna have to basically figure out in their own way what the best choice is for them. Okay, so they're given the option to either confess the crime or they can deny. Okay, and they'll just have to these are the choices. So if they both confess to the crime, right, and they say that we did it, they're each gonna get 10 years sentences in prison. Okay, but if Diane confesses but Jack denies, because Diane confessed, she's going to be able to walk free, while Jack is going to spend 20 years in prison for denying that he did the crime. Okay, and the same way, if Diane denies but Jack confesses, he snitches out and betrays his friend, Diane is going to get 20 years in prison while Jack is going to walk free. But if they both deny, they keep silent and they don't say anything to the police, basically they're just cooperating with each other, they're not telling the police anything, they're only going to get 5 years in prison. So the way this payoff numbers are set out actually leads to something really interesting, which is known as the prisoner's dilemma. Okay, so once we analyze this, we will see that it's why this is a dilemma, basically. Okay, so let's see, how do we do this? So if we are looking at it from Diane's perspective, right? Okay, so we're gonna have to consider. So she's gonna have to consider, what Jack does, right? So if Jack confesses, right? So this column doesn't exist right now. So if Jack confesses, you're only gonna be looking at, what the best option for Diane is. Her options are to either confess or to deny. So if Jack confesses, what is her best option? To confess or to deny?
To confess.
Right? Because if she confesses, she only gets 10 years in prison, as opposed to, if she denies and Jack confesses, she's going to get 20 years. So she's going to choose to confess.
So they will both confess,
yes,
because they have the chance to be free.
Exactly. So we're getting there. So now let's say we did this column, right? So which was, what Diane would do when, if Jack decided to confess. So now we're going to take a look at Diane's best response if Jack chooses to deny the crime. So if Jack chooses to deny, like this column doesn't exist right now, we're only looking at this column. So what are the two numbers? Which one should she pick?
She should definitely choose to confess.
Yes, because if she chooses to confess, right, when Jack denies, she's going to get to walk free. But if she denies and Jack denies, she's going to get 5 years. So those are the two choices, right? So she's definitely going to choose to confess when Jack denies. Okay, so now let's switch perspective and take a look at it from Jack's point of view. So for Jack, right, he has the option once again to either choose to confess or to deny. And, it's not just about him. He's going to have to consider what Diane might do. So if Diane confesses, right, if he thinks that Diane is going to choose to confess, what is his best option?
To confess.
To confess, right? 10 versus 20. And the same way, if Diane chooses to deny, what is his best option?
To confess also.
Yes, to confess, right? Because, that way he can go free rather than, having 5 years. So from what we see here, right, the dominant strategy for both of them
Is to confess.
is to confess. Both confess, right? Regardless of what the other person is doing, the dominant strategy is to confess for both of them. And when we have something like this, so when both people have a dominant strategy, right? When both people have a dominant strategy, so here the dominant strategy for both of them was to confess, right? We call that a dominant strategy equilibrium. Okay. So where is that cell?
What? Sorry, I couldn't hear.
Where is that equilibrium where, both people have a dominant strategy?
Here, if they both have confess.
Yes, so both confessing, right? So this is the dominant strategy equilibrium. This is also the Nash equilibrium in this case. Okay? So every dominant strategy equilibrium is always going to be a Nash equilibrium. Okay? So every DSE, so dominant strategy equilibrium, is also a Nash equilibrium. But every Nash equilibrium is not a dominant strategy equilibrium. So we just saw that in the previous case, right? We had a Nash equilibrium, but not a dominant strategy equilibrium.
Okay, so DSE is always Nash, but
yes,
Nash isn't always DSE.
No, that's correct. So every dominant strategy equilibrium is going to be a Nash equilibrium. But remember here what we saw. Hello?
Hi.
Hi, can you guys hear me?
Yes.
Is stuck for some reason. Okay, I can't really scroll back to the last page, it seems like. I don't know what's going on, but we can come back to it in our next class. Anyway, so from what I want you to take away from this prisoner's dilemma situation is that the dominant strategy here was for both people to confess, right? Because they were both acting in self-interest, right? So this is sort of where the paradox is coming from. Wow, what just happened? So because let's see, if they both, the dominant strategy was to sort of, act in their own self-interest and protect themselves at the expense of the other person, right? But let's see, like if you take a look at this cell right here, if they had sort of cooperated, right, and kept shut or denied, right, they could have both gotten a lesser sentence, right, which is 5 years, right? So which would be much better than the 10 years that they would have to do if they confessed. So this is sort of the dilemma with prisoners, with this situation, where the way this matrix of payoffs are set up always leads to a situation where it is better, or like they're gonna choose to confess or defect, at the, they're trying to protect themselves at the expense of the other person, not trusting the other person, and they're never going to cooperate even though it is mutually beneficial for them to cooperate and get a lesser sentence. Okay.
Because they think that if they confess and the other one denies,
Exactly.
then they have the.
So this is something that we always see, like we actually see this in real life too, right? If you think about Coke and Pepsi, we're gonna make sure to have an example of that next class. So remember, they might agree on some sort of a strategy, but then they think, by undercutting the other person, the competitor, they can cheat. I can have higher price and I can have more profit. So this tendency to really just protect yourself and undercut the other person always leads to this sort of um, defect in dilemma, right? Where you could be like benefiting, both of you could be benefiting by cooperating, but because you don't trust the other person, and you always think that you're thinking for yourself, that you always end up in a place like this, where you are basically harming yourself. Okay. So we will come back to this. We didn't finish as much as I wanted to, but we'll come back to this in the next class, and hopefully we can finish oligopoly. Thank you so much, guys.
Okay. Bye. Thank you.
Bye. Thank you.
Bye bye.